This video demonstrates workflow number 2, process, part batch, and test, and highlights automated manufacturing engineering capabilities, including automated sheet metal batch unfolding coupled with design for manufacturing DFM functionality. DFM performs a manufacturability analysis on each sheet metal part, identifying potential fabrication issues before production begins. These capabilities showcase how the manufacturing engineering process can be automated by eliminating many of the labor-intensive steps traditionally required to prepare production information for the shop floor. The workflow also includes the automated generation of sheet metal nesting programs, press brake programs, panel bender programs, and robotic folder bend programs, further reducing manual engineering effort while improving speed, consistency, and production readiness. With optional integration into ERP and MES systems, the Global Edge Engineering Assistant significantly streamlines and accelerates engineering and manufacturing workflows, improving efficiency, reducing manual effort, and enabling faster time to production. Step 2.1 starts with the automated production work queue, which processes daily orders that can either be manually selected or automatically downloaded from your ERP system. The work queue streamlines and automates labor-intensive tasks throughout the quoting, engineering, and manufacturing workflow. Step 2.2 provides automated sheet metal batch unfolding capabilities that generate DXF flat files directly from 3D SolidWorks sheet metal CAD models. The process incorporates extended data containing the required manufacturing parameters, enabling the automated generation of nesting layouts, bend programs, and production schedules. Step 2.3 provides automated CAD part analysis of complete sheet metal part parameters to serve as a foundation for manufacturability testing, automated routing, bend program, and sales quote generation. Step 2.4 features automated routing generation, a capability that analyzes CAD part parameters and matches them to optimal manufacturing processes, bend processes, and machine tool parameters to produce optimized routing steps. Step 2.5 performs automated manufacturability testing, which compares CAD part parameters with the corresponding bend process to identify potential fabrication errors before the design is released from engineering. Step 2.6 enables automated bend program generation by embedding extended manufacturing data within DXF flat files. This data includes parameters such as material type, material thickness, bend tooling, bend radius, standard bend processes, required delivery dates, and production quantities. Nesting, bend program, and scheduling software can then use this information to automatically process production batches.